Apollo 13, coming after 2 successful lunar landings, really began to mark kind of a watershed in the, at least in the public relations rationale for the missions, where the shift was from accomplishing this national goal to doing useful science. What was going to be the scientific return of that mission and that particular lunar landing site at Fra Mauro?
Well, half of the effort we're going to do at the moon was very similar to what had been done on both 11 and 12, and that was to lay out a set of scientific experiments involved in the ALSEP packages.
It's the lunar surface.
Lunar surface
package.
Right. The second part, which was to be probably more involved, and at least a hope of being better field geologists to do a better sampling, was the EVA, the second EVA. And in our case was to explore the countryside up a slope toward a feature called Cone Crater in the Fra Mauro region of the moon. And by strategically sampling up toward the crater, you would be sampling material that at the an outside ray of the crater would be the deepest material, where the crater normally forms on the moon, or on Earth for that matter. If it's due to an impact facet, it inverts. It's an inverted flap. So if you're sampling up a ray, the farther out stuff is the deepest stuff within the crater, and as you get up near the edge of the crater, you're sampling literally at the surface.
And it really wasn't known at that point, was it, whether that crater was caused by impact, or was it known to be an impact crater, or was it still thought it might be a volcanic?
No, it was. I think it was pretty much ascertained it was an impact crater. The whole area was hypothesized as some of the erupted material that had come out of the Imbrium Basin. That's the, if you can envision a face in the moon, that's a left eye in the moon. And so when that big meteorite impacted there, it caused splash material, molten rock, and part of that splash formed the Fra Mauro Hills, which was south of that eye in the moon.
Of course, the early missions, 11 and 12, both had to land in relatively smooth areas because the targeting was not that precise. By the later missions, you were getting more confident in the landing procedures and willing to go into areas that might have some of the highlands or at least crustal materials in them, as opposed to the basalts.
Well, it was driven by confidence in the capability of the LEM landing capability and steerage. But also, if you're going to properly sample the moon, at least in the committees that formed to look at the site selection, you had to become more diverse in where you went to get a proper sampling of the moon.
Mm-hmm. We're getting back to the crew assignments, the crew positions just before flight. Of course, you were on a crew where a change was made in the last week when Ken Mattingly was exposed to the measles, pulled off and replaced by Jack Swigert, who had been a member of the backup crew. And how confident were you and Lovell that Swigert was going to be able to step in at that late date and do the job of command module pilot?
I certainly had no problem. If you looked at Jack's background, he was chosen for the program as a test pilot at North American Aviation and working on the initial design of the command and service module. So that was his background even when he became an astronaut. He was the astronaut assigned because he was a support crew of Apollo 7, was his first assignment, to work with mission control people and engineering to devise the initial set of malfunction procedures that were to be used for the command and service module should anything fail or go wrong. So Jack was very versed on the technical aspects of a command and service module and flying one. So I had no problem at all with Jack stepping in from a technical, called a flight safety standpoint. Now it did change our practices for those last few days before launch. Normally in that period you would literally quit training, go off to a beach house, which was an isolated area at Kennedy Space Center with no phones, where we could go off and be isolated and sit around. Generally you might read your checklist, that kind of thing, and go a little fishing on the beach. but otherwise kind of get rested up, if you will, for the launch and the subsequent mission. With that change, though, we did go back into the simulation mode through most of, I'll call it, critical phases of the flight, like launch, or lunar orbit insertion, or transit Earth injection, leaving lunar orbit, rendezvous, and more as a test that even though prime and backup used the same checklist and the same procedures, was there some verbal difference in how we translated calls back and forth. So it was more an exercise in that to make sure that the backup crew hadn't developed something different that way than we had. I frankly felt, having been a backup on 8, 11, later 16, that I was not as capable, but maybe even a little more capable of flying the mission than the prime person. Because the prime crew, if you looked at it, they got off onto other tangents. They got taken out of training to do press conferences, invent a patch, worry about who's coming to the launch, personal preference kit. So all of those times they were out of, call it, the training mode. As a backup, I was in a simulator or continuing training. So I think if you looked at the records, you would see a backup crew generally might get a few more hours training than the prime crew.
Yeah. Of course, the one element that might be missing when it happens late in the cycle like that is this, and you alluded to it, is this element of teamwork, the ability of building these people together as a tightly knit, almost subconsciously functioning team.
That's absolutely true. But and behind that, there obviously was an emotional effect for, call it, consideration for those two people who had to transpose roles, in particular, in a way unfair to both. The way you mentally approach these things as a backup, within several weeks of launch, I mentally tried to convert my sense away from thinking I might fly to not feeling so bad that I wasn't going to get to fly. And I'd done all the work. I was capable of flying a mission, but I wasn't going to get to fly. So I sort of, inside, sort of mentally pulled away in a sense of I'm not going to really get to go. The prime crew guy's not going to get hurt, and he's going to get to fly it. And so that there's that mental transposition, I'm sure, happened in the case of Jack Schweigert. Whereas if you're the prime crew, within that last few weeks, you really start getting, this is real. I mean, this is really going to happen when we said it was. We're going to launch. And occasionally you just sort of feel a few little butterflies here and there during the day or whatever. You start thinking about it, you look up at the sky. And so you're more on that go side of the emotional train. And I think it was very difficult in that sense for the two parties having to do that shift with 2 days to go.
I always had the sense that Mattingly, and perhaps you and Lovell as well, somewhat resented the decision to remove him from the crew because you really didn't feel that he was going to get the measles.
Well, it wasn't just that. The meeting, incidentally, was with Dr. Payne. It was in crew quarters at Kennedy Space Center. It was Dr. Payne and Deke and Jim Lovell and myself. So that was the meeting. Jim made a request to go ahead and fly. Not so much that he wasn't sure whether or not Ken would get the measles, but on the basis that the timing of the exposure to the incubation of where Ken would have an onset of measles, we would have been well past the lunar activity. And so it was on that basis that Jim said, and his sense was, you know, if you're sick, there's no nicer environment to be in zero gravity. It's a comfortable environment, just heading back home. And but that was not accepted.
Yeah. Just do the conservative thing and make the change, although that had risks of its own entailed with it. So. Well, during the launch of Apollo 13, there was an anomaly, and I don't know how apparent it was to you on the flight crew. I'm sure you were very, very aware of it when the second stage center engine shut down early. Did you think that you were going to make it into a safe orbit when that occurred, or was there some flutter that this may shut us down and we may not make it into a safe orbit?
Yeah, there was a brief episode from where I was on the right side. At least, certainly, you felt the vibration. It was like for a few seconds, like the feel of maybe you're holding a jackhammer, kind of an effect, and it went away. Then over on the left side, of course, Jim and Jack could see the center engine light come on that it had shut down, and reported it. My main concern then was not could we reach Earth orbit, but would we have enough fuel left to still commit to the lunar mission? And that I thought we'd probably end up in Earth orbit flying an alternate mission, which we did have in our plan.
Is that because with that engine shut down, you were going to have to tap into some of the third stage propellant to make a safe orbit?
Correct.
And that wouldn't leave you enough then to do the translunar.
To commit to leave Earth orbit for the moon.
And I guess you did have to get into that propellant a little bit to make orbit.
Yes, we did. We had the longest insertion time of the program.
And that was, I think, as I recall, it was what, normally about 8 or 9 minutes for a Saturn V.
I don't remember the exact numbers, but I know it was the longest.
Yeah. But the engine did give you a physical sensation before it shut down that something was not right.
Well, yes. That what happened was there was a instability in the feed to the engine, called effect called pogo, and that varies the thrust level considerably, and that variance in thrust, resulted in a chug, if you will, a vertical chug up the stack that gave us this chattering. As I understand it, pegged out the accelerometers on that center engine, which is on a set of cross beams. Later, talking to Marshall people, they were happy it did do its shutdown when it did, when it hit a low pressure point, because much greater excursions in that G level may have caused structural damage to that cross beam effect, and of course even more catastrophic effects.
Fred, we were talking about your launch on Apollo 13 and the shutdown of that center engine on the second stage. So you did, as it turns out, have adequate propellant not only to make a safe orbit, but to get you en route to the moon. And as I recall, then the early parts of your flight were really very uneventful from that point up until the oxygen tank exploded when you were about 2/3 of the way to the moon. Did you have any inclination when that first happened that you had that kind of a serious problem when the tank exploded, or was it still, was it obviously a potential showstopper in your minds, or was this just something that, hey, what was that, and go about finding out what kind of a problem you really had?
Well, I'll speak from my standpoint. At the time of the explosion, I was in the lunar module. I was still buttoning up and putting away equipment from a TV show we had completed, and really we were subsequently going to get ready and go to sleep. I knew it was a real happening, and I knew it was not normal and serious. Just at that instant, I did not necessarily know that it was life-threatening. Obviously, I didn't know what had caused it. Within a very short time, though, I had drifted up into the command and service module to my normal position on the right, which encompasses a number of systems: the electrical system, cryogenics, fuel cells, communication, environmental systems. And there was, just looking at the array of warning lights, and there were quite a number on at the time lit. There's red and yellow lights and a caution warning light matrix, as well as a computer restart light and a master alarm on. There was confusion in my mind because we had never had a single credible failure that would have caused that number of lights on at one time. One thing, though, just looking over the instrument panel, that became very clear in short order was the fact that the pressure meter, the temperature, and the quantity meter needles for one of the oxygen tanks was down in the bottom of their gauges, and these are different sensors. So it was unlikely that this was false. So it effectively told me we had lost one oxygen tank. My emotions at that time went to just a sick feeling in the pit of my stomach, because I knew by mission rules, without reference, that meant the cancellation of the lunar mission. We were in an abort mode, but still not life-threatening, because we had a second oxygen tank, I thought, which looked to be still there, and we'd have stayed fully powered up and then just took an abort mode to come back home with everything fully powered. It took some minutes to become obvious that there was, for whatever reason, that there was a leak that the explosion had caused in the second oxygen tank, either the tank or one of the lines, and but a small leak. And when it became obvious it was dwindling or losing oxygen, then the handwriting was on the wall that the command module was going to die, have to be powered down, because without fuel cells, all was left was 3 small batteries, 44 amp hours each, that we were going to need to execute an entry when we got back. So it was going to have to get turned off. So that's kind of the emotional cycle I went through in this period. We probably failed to communicate properly in that early period to Mission Control, to tell them about the not just the sound, the bang, but also about what we saw out the window, because even then, when I first got back into position in the command and service module, out the window was a sea of debris around the vehicle. And had we reported that, I think Mission Control in a much quicker time would have gotten up to speed in the same way that this was real and not a false set of readings or instrumentation failure, which I think they wrestled with for some 18 minutes, if I recall.
Yeah, if you go back and look at the transcripts, there was obviously a period of time in the control center where, at least in the minds of some of the controllers, if not all of them, there was still a possibility of saving the lunar mission. And yet, I think what you're saying is that from the crew's point of view, that possibility had long since gone away.
Oh, absolutely. Within probably the first minute to 2 minutes, I knew we had lost the mission. As
the crew's lunar module expert, once it became apparent that you were going to have to use the lunar module as the lifeboat, a role that it was really not designed for, how confident were you that it could be used for that? Well, I was confident it would power up and provide the resources we needed for a time. What was not clear to me just instantly was that we could make it last as long as we had to make it last, namely roughly 4 days. I did have a point after we completed the first the activation and then the first maneuver using the landing engine to get us back on a course that would take us around the moon, to do some back of the envelope arithmetic on a checklist, which I still have that page at home, that I calculated the consumables on a power down, I assumed, and I figured we would run out of the critical element for me at that point was water, that we would run out of about 5 hours before what was then the entry time in the plan that had been conceived. I felt safe with that because I also had data from LEM 5 on Apollo 11, where we left that one in orbit. Before Neil and Buzz left it, they turned off the water valve deliberately as an engineering test. And the first major component in any system, one of the guidance and nav components, failed at 8 hours. Well, this was because without water you can't cool it. You can't cool it. Temperature goes up and it shuts down. Right, and it would fail. And so, just based on that one data point at least, I figured we had maybe enough margin to make it even in the case of running out of water 5 hours before entry interface. So water ended up being the most critical component or consumable on the spacecraft? No, actually the most critical consumable I didn't consider. That was the lithium cartridges. It didn't even occur to me that we had these cartridges, LiO or lithium cartridges, were used to scrub carbon dioxide out of the air, and I completely forgot about it. That the only spares in the LEM were down on the Mesa, a thing you would have deployed on the lunar surface, and frankly there wasn't enough spares, as I recall, to have sufficed anyway for 4 days. So that was the commodity we had the shortest quote supply of, and the ground people on the ground subsequently worked out the way of implementing the use of the square, a different shape cartridge from the command module, which there were an abundance of,
to deploy in the lunar module.
Did you ever reach the point where the buildup of carbon dioxide was becoming noticeable in the atmosphere in the lunar module?
As I recall, we did break the red line and got a master alarm on, but I never felt physically any effects of that at that level.
One of the things that I recall there was quite a bit of debate about, I don't remember how long it went on, was whether or not to use all the available propulsion, turn the spacecraft around and head it back to Earth as quickly as possible, or go on around the moon, use the moon's gravity to send the spacecraft back a little bit longer, but it didn't require using the service module engine. Did you have any hope that that service module engine would have worked if it had been needed?
Well, we were not involved in that set of arguments again in the choice made. I frankly would only say now, in historical sense, I'm glad they didn't make that choice. What we saw when we separated the service module just before entry and took a lot of pictures, but also observed, it looked like the high gain antenna that protruded out near the rear of the service module had been bent over and actually had impacted the engine bell on that SPS service propulsion system engine. And obviously if it either cracked it or dented it even slightly, would have probably had an instability in affecting the use of that engine, and may have even exploded. So it was a good decision. Yeah,
I think when people saw the pictures that you brought back, they would have agreed with that. So as it turned out, you ended up completing an orbit around the moon, using the moon's gravity to head you back to Earth. What was your recollection of the high points and the low points in that transition back to Earth?
Well, again, there wasn't too many high points. Probably the best, at least to have that opportunity, was to view the moon as we went by, which is quite a different variety body than the Earth. It's rather lifeless, and get to see the backside, which is quite different from the front. Mountainous, very hilly, only a very few small maars or seas, the so-called smooth areas, and that was exciting. Jack Schweiger and I both had cameras out and shot quite a number of pictures while we passed by briefly. The lows probably came as the ensuing days when the cold vehicle had gotten very cold. There was no temperature meter in the lunar module, but I would suspect it's 35 to 40 degrees, somewhere in that range, because it froze the water tanks in the command and service module. So I'd suspect with the little equipment we were running, we were a little warmer than freezing, but not a lot. And that kind of wore on you after a while. We did not have adequate clothing to handle that situation. We did put on every pair of underwear we had in the vehicle. Jim Lovell and I wore our lunar boots, the boots we would normally put over our spacesuit boots on the lunar surface. But the material in the clothing, we wore two-piece suits, the pants and the shirts, because of the earlier loss of the crew and the fire, had been changed along with a lot of other materials in the vehicle to a beta cloth material which tended to fray, so it was coated with Teflon to prevent fraying, and that Teflon just almost assumed the temperature of the environment, so it was kind of like wearing a cold coat or a cold pair of pants with not probably some degree of insulation value, but not what you normally have even if it had been plain cotton material.
How quickly after you got into the lunar module began to power things down did it start to get cold?
From my power down, it probably took almost a day to get all the way down, because there was lag, thermal lag, and from where the vehicle set at, call it normal temperatures, to lose that much heat transfer without the compensating heat from all the equipment being on that no longer was on.
But you were in a passive thermal control mode, as I recall, rotating the vehicle so it got constant exposure on all sides to the sun. Did that?
Yeah, we were. I'll call it in a pseudo passive control mode. We had great difficulty manually setting it up as you would have done through the computer in the command and service module. So it was continually rolling, but not in a perfect alignment with the normal x-axis, the one through the center. So it was kind of cavorting in various directions. So I'm not sure it was really getting even heating on all sides.
Mm-hmm. How did the ground and the flight crew work together during this period of time to handle this great concern that I know everybody had about having to throw out 6 months worth of procedures and checklists and start from scratch? And was that a big concern from the crew's point of view?
There was a big concern from my standpoint, and with one respect, and that was just knowing that for the situation we had with the loss of the mothership of the command and service module, and even though using the LIM as a lifeboat had been conceived, I knew there was no hard procedure and no hard alternate flight plan that someone could go grab off a shelf and say, this is what we're going to use. So I knew there had to be a lot of brain power brought to bear to invent this alternate plan, a little in real time. And some of that real time started immediately. For instance, the lunar module power-up, we used an activation checklist, but that was quite lengthy to be used in lunar orbit to prepare the vehicle for landing. And we were time critical, so that was done totally ad hoc with live communication through the Capcom to those in flight director and those in mission control to ascertain what we would leave out of the power-up, what we would cut out, which is I went through the pages. I had a Pintail pen. I would just X through segments of that activation procedure, and we just rapidly moved through it. It was interesting that when Jim Lovell and I, after the flight, went, just out of curiosity, went back into a lunar module simulator, we could not replicate the time of that activation in a nice calm conditions of a ground simulator that we had done in flight.
I mean, you couldn't do it as quickly?
Couldn't do it as quickly, so I'm guessing adrenaline does help.
Well, of course, one of the concerns is that with a complex vehicle that's already crippled, as this one was, that if something is done out of sequence or if a process isn't followed in precisely the right order, that some additional damage may be done. And I recall that the flight directors at the time seemed to be most concerned that even though they had the situation under control, that if a mistake were made, that this narrow margin would suddenly evaporate.
That's absolutely correct. I have to give my hats off to the crispness of response, as I said, in this, call it ad hoc mode. To me, the two biggest challenges and the times I felt the most pressure during the flight was, number one, the lunar module activation and the haste at which we had to do that. The second one was the power-up of the command and service module, the mothership, which Jack Schweiger and I executed, because it was, again, a new, had to be invented procedure by people on the ground that we had never done before. And anything of that nature, had we known we were going to do it before flight, we'd have practiced it dozens of times in a simulator. And here we could only read through it a few times, which we did, and sort of walk through the switches and circuit breakers as to the play of that power-up, but then had to do it again in a fairly short timeline.
And was this when you were getting ready to come back from the lunar module to the command module to re-enter?
Prepare it for entry, right. And that was the second time I felt a great deal of pressure, because we're going to have one shot at it, and it had to be right.
Well, of course, it was a real tribute to that vehicle that it withstood being powered down, frozen, inactive for all that period of time and then came back to life and did its mission to get you back through the atmosphere.
Absolutely. You could say the case for both vehicles. The lunar module, to the degree we took the power down and the temperatures that evolved, violated every redline specification on literally every system in that vehicle, and similarly so in the command and service module, which obviously had never planned to be shut down.
Were you aware at the time of the intense worldwide interest that had developed over your plight in getting back?
No, we were not, and that was never discussed on the airways of what quote the reception might be by people in the U.S. or around the world. In the back of my mind, I had a concern that it might be taken negatively. That here we had failed. It was planned to be the third landing mission, and we weren't going to accomplish it. And I could envision the headlines of NASA waste $100 million or something on this mission that failed. And it was kind of thing bothered me, not from the standpoint of I felt I was the cause of the failure, but being a part of the team as a whole. You just didn't want to be a part of a mission that failed, and frankly, I worried that it may affect the program in some way, or even halt the program. And I certainly wouldn't want that on my record, that I was involved in something that caused that.
And of course, the mission was a failure, but it was not perceived that way. It's viewed today as one of NASA's shining moments.
Well, I think that for whatever reason, I guess it was because we were human beings and people saw us as in trouble and saw the work that had been done and had admiration, and the salvage operations, if you will, that enabled us to get home, and reflected more on that human interest side of it rather than the other side of what monetary side of it and what wasn't accomplished in the original antenna mission, which I'm very grateful for. I think clearly it offers a graphic example and a very dramatic example, which is why it was chosen for a movie versus other missions, which were more successful, obviously. Is it does make it very clear what can happen if you do have the right people, the right skill mix, that are trained and they're assembled in this team, and they work together under right leadership. What a miracle can happen, and that's what was the case of Apollo 13.
Were you surprised at the time by the outpouring of public sentiment worldwide after you had gotten back?
Yeah, particularly worldwide. I figured that when I saw that that was the thought people had. I certainly felt the United States that would be the case. Because it was predominantly a United States program at that point. But I was really surprised by that worldwide effect, and as I saw that personally in visits, we made State Department trips to various countries and saw that effect as we went overseas.
You alluded to the fact that even though you didn't get to conduct the lunar landing, you did get a view that very few people have had, and that was a nice close-up view of the moon. Did you have much of a chance to see the moon as you were approaching it, or was that time when you went behind the moon and started the free return trajectory back to Earth the only real close-up view you got of it?
No, that was the time as we passed around the backside and came out, was the only time we had to really observe. And as I said, Jack Schweiger and I at least got cameras out and took a lot of pictures. We had a maneuver, another use of the LEM landing engine, scheduled a couple hours after we passed the moon, the low point around the backside. And Jim kind of cut short our touristing, looking at the view to make sure we got ready to execute that maneuver, which was a very critical part of the plan, because that cut our time short by I think 10 or 11 hours, which really made our consumables then pretty healthy.
Of course, Lovell had been there once before. So
Jim had been there, and I think he was again, having been there now twice, and he was, I think, bothered more at that point maybe by the fact he had lost the chance to land. And of course, he'd been a commander. I guess in that respect, you clearly feel more accountability for the total happenings than if you're the rookies like Jack and I, that for all we knew, I might even get back.
One of the things that was, of course, a concern was using the lunar module engine to do something that it really, and the lunar module to do something it hadn't been designed to do, and that's to propel the whole spacecraft stack docked with the command module. Would you have been confident doing that if we hadn't had the tests of that system in that mode on Apollo 9?
Well, yeah, I was going to correct you that it had been thought of as being used for really for the purpose of the failure of the service propulsion system engine on the command and service module as you entered lunar orbit. If it failed at certain times, you would use the LEM descent engine to do that. No, clearly there had a lot of validity to that being an acceptable, not the standpoint of the engine running, but standpoint of control of the stack, the guidance, nav, and control, to have had that done on Jim McDivitt's Apollo 9 mission. And that was the purpose, was to prove out that use of that engine for in the LEM to handle that abort mode.
You had one other technical problem, as I recall, and that was the ability to align the platform for that important engine burn. You had to have an accurately aligned guidance platform. What was involved in getting that done?
Well, there were two alignments that we had to deal with. The first one, frankly, was done by right after the LEM powered up, if we're backing up to then, by taking the Noun 20, or the gimbal angles readouts from the command and service module, which had a good alignment, and manually we had to convert those to the LEM axes and account for the misalignment in the tunnel. We had marks in the tunnel when you docked. You didn't always get 0, 0, so we had a yaw misalignment to deal with, which we mathematically, manually cranked in, and keystroke those into the LEM computer, and that talked the platform to that alignment. So that was the way we devised the initial alignment of the lunar module platform, which was normal, which you'd done in normal activation.
Right, and at that point the command module was still a functioning vehicle.
Still a functioning vehicle, and that frankly was also the time criticality of power-up, was to get that alignment done, because we knew we'd be in deep trouble getting a good alignment if we had not executed that in time before the command module died, because of that sea of debris around us. You couldn't see stars. I mean, a little ways away from the spacecraft, those charred pieces of the thermal blanket, shiny material, or the frozen oxygen, they look like stars.
Of course, they just stayed right on.
Stayed
right
with us.
You.
So the second alignment was done to do two manual burns, and that was done fairly simplistic. And what was the way that was done was it was a sight in the commander's window called a coas, sort of like a gun sight. And with that, Jim Lovell aligned roll on using the points of the cusp of the Earth. It was a half Earth. And with that alignment, he would pitch the vehicle until I could pick up the sun looking out the periscope, which was an AOT, and the LEM at the upper point of that view was up about 60 degrees. So when the sun first peered in that, I'd tell Jim to freeze, and he'd stop the maneuver. And then I keystroked in a small, low-power backup computer, a body axis freeze, which would give you cross needles on your 8-ball. And if you kept those centered, that would freeze at that attitude we were at. So from that, with that for use for attitude control, we executed two manual stops. Well, one manual stop-start of the descent engine. Very short burn, 19 or 21 seconds, something of that sort. And then a second maneuver later using that same alignment protocol, using 4-jet 100-pound rockets on the LEM for, again, another velocity change to affect our entry path.
This was to set you up on that very very narrow entry corridor that you
Right.
had to have
That was to get us a
safely
line for the entry corridor.
But the guidance platform had been, as you pointed out, aligned early on. Was the concern that it would have, in that amount of time, drifted off, and you needed to assure that it was still accurate before doing that course correction en route back to Earth?
That's correct. Yeah, well, if you look at it, obviously every one of the maneuvers were important and had to be reasonably accurate. Probably the two most paramount would have been the one that first got us on the right path to go around the moon, and the second one, which reshaped the trajectory to get the 10 hours relief on the return. The others were coarser burns, which obviously if they tracked a while and saw that it didn't turn out right, we could have repeated those. They were very small maneuvers, tweaks, I guess is the terminology used. And we could have executed several of those.
Of course, one of the things that was significantly different about your entry into the Earth's atmosphere from previous Apollo missions is that you still had the lunar module attached as you approached Earth and had to get rid of it. Was there any concern that the lunar module and command module might collide as you're coming back into the atmosphere?
No, I didn't worry, because that was again part of the plan that Mission Control had worked out. We set up an attitude and pressurized the tunnel between the two vehicles. So when we separated the lunar module, and it was quite a jolt, it actually projected it away from us, out to the side. So it dramatically changed its path, so again to lessen that likelihood that we would have this collision.
But that is something that had to be taken into account. You just felt it was properly planned for.
Oh yeah, that was just part of that final set of steps that had to get done. Before that, even the attitude at which we separated the service module in a similar way, to make sure we wouldn't drift back into it, where we separated and shot the pictures to try to collect that piece of data to support the accident investigation.
I would imagine after you had gotten back in the command module, had its full power more or less available to you, that this cold situation took care of itself. Things warmed up pretty rapidly at that point, didn't they?
Yes, it did. And we powered up some of the things on the LEM earlier too, so that the combine of the two, when we knew we had adequate power left in the lunar module even, it felt great, because it did get pretty much back to the normal temperature by the time we hit entry interface.
Probably a very nice sight to look out the window and see those parachutes above you.
That's the time in Apollo where you really knew you had it made, when you could see the final deployment of the main chutes, at least two of the three. Then that's probably nothing else could go wrong till you splash down.
Well, you mentioned that in your mind, and probably in Jack Swigert, there might be other chances. And of course you were on backup crews for other lunar missions. Were you pretty confident then that you would get another chance to go back to the moon?
Well, yes, I was. I knew that the program had been altered in the flow of the schedules, because they had injected Skylab in between what was then to be the ending missions, which would be Apollo 18 and 19. Having cycled to Apollo 16 as a commander behind John Young, with an initial crew assignment of Bill Pogue as the command module pilot and Jerry Carr as the lunar module pilot, I did hope and expected that I would get a chance to cycle through that backup assignment and we would be the crew for Apollo 19, which at that time was advertised as the last mission of the program.
Yeah, so it was a very good prospect that you would have made an Apollo flight and had that opportunity to walk on the moon until those last two flights got canceled.
Yeah, I don't recall how long we were in that training cycle. Probably a couple of months, 2-3 months, where that eventuality did happen. 18 and 19 were canceled. Bill Pogue and Jerry Carr were cycled then into the Skylab program to give them an opportunity to fly. And I inherited Stu Rusa and Ed Mitchell off of 14 to complete that deadhead backup assignment.
In a sense, ironically, the loss of Apollo 13 and the near loss of the crew on that mission was probably a factor in the decision to cut short the remainder of the program.
I cannot really attest to not having been involved in that decision making. What was the cause? I frankly surmised there was more one of budgeting and the hiatus of of trying to cycle through a Skylab and then get back in the quote lunar mode over a fair number of years. It would drug that out, and the thought of the agency of getting on with the next program, whatever that may be. I guess in those days there was probably still a vie-in between space station or shuttle, is call it quote the next step, and so I think it was that concern of not having sufficient budget to both continue as well as have sufficient budget to get the next program underway.
And of course it wasn't much beyond that the shuttle became a very serious consideration, and the costs associated with getting the shuttle off the ground were a big factor.
Yeah, and there was probably certainly a feeling of risk versus gain. We were flying vehicles that were at best redundant and two-string, and rather precarious sitting out at the moon. So there probably was, from the landings that had been made, were already committed to be made. There was probably in NASA's management's view a risk versus gain of, should we take this hiatus from the program and then come back at it again and have that face the risk of eventually losing a crew.
Of course, in hindsight, and many of the people in the country today weren't around when Apollo flew, but it's perceived as being the high point of NASA's career as a space agency, and yet in reality, in addition to the crew that we lost in the Apollo fire, there were a number of really close calls in the Apollo program.
Well, I think that the reason it's it's looked at that way are several. One is the mission. I mean, there's no question the thought of going to the moon in those days, was paramount, obviously, and obviously something people can envision, and there's no question it was exceptional challenge. So that just that picture of what you were having accomplished in Apollo brought it obviously was a major engineering challenge, probably in the 20th century. The only tougher one or equal, or in any way form equal, was the Manhattan Project, driven in a similar way on a time domain too, that evolved the atomic weapons. So clearly it stood out in that regard.